Okay, so first I want to make sure we write down the rules of the discriminant. Okay, I'm going to write the quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4ac divided by 2a. Hey, the discriminant is the b squared minus 4ac. It's the number under the square rooty. Okay, it's the value that's under here. And it tells us something. That's what the discriminant is. Those things match. The discriminant, if it is a number, once we evaluate this and we get it down to a number, if the discriminant is greater than 0, a number that's positive greater than 0, you're going to have a graph that's going to it's going to have two x-intercepts. So I'm going to say two real solutions. I'm going to say two real, and I wish I had a little bit more room, but anyway, two real solutions. They could be called solutions. They could be called roots. They could be called zeros. They could be called x-intercepts. It's going to have two of them when it's greater than 0. When it's equal to 0, it's going to come down and touch just once and then go right back up. It's only going to have 1 point, one x-intercept. So you're going to have one real root or solution or 0, whatever they call it, or x-intercept. They can use any of those words. They're all interchangeable. And then the last one that we have is if it's less than 0. If it's less than 0, you're going to have no real roots, but you'll have two non-real. Okay, the graph will look something, it could be either going uphill or downhill. But the non-real means like 3i or negative 3i. And they're not always, actually, I think they are exact opposites or conjugates of each other. That would be a better term to use. Remember conjugates, if you add them together, they're a zero pair. But another form could be like 2 plus 3i and 2 minus 3i would be another format for x-intercept. Sorry, it's going to catch up. What if I turn my light off? Hang on. I don't know. I'm still getting glare from somewhere. It's probably from over here. Oh, it's coming off the wall. Okay. Sorry that it's a little light here, guys. If I could cover it, I would. But if I zoom in, we don't have a problem. Okay, so we just did one in class. I'm going to go pull up what it was. I put the work somewhere. There we go. It was 10. It actually had the letter R, but x squared plus 8x plus 10 equals 0. And I asked you to tell me what is the value of the discriminant. So we're going to go ahead and do the formula b squared minus 4ac. Again, I'm going to reiterate that anytime you square a number, this is always going to be a positive number. I don't care if it's a negative. If that was negative 8 times negative 8 is positive 64. So if you're actually substituting in, you would put an 8 here and have 8 squared minus 4 times a times c. 8 squared is 64. Negative 4 times 10 is negative 40. Then times another 10, I get negative 400. Different signs subtract. It looks like we're going to get negative 336. Okay, so that's the discriminant. If I just ask a question on the test, evaluate the discriminant? That's the answer. If I ask you how many zeros does it have, and your choices are A, B, C, and they only have 3 choices. Actually, they might put a fourth one and put all real numbers, and you're like, what the crap is that? Because there's only 3 answers for this. Your choices are you either have 2, 1, or you have none. So I would have here 2, 1, none for my choices. This one, because it's less than 0, it should be no real. It doesn't mean there's no solution. If it asks how many solutions does it have, I want to say none real. This will be 1 real, 2 real, none real, but it'll have 2 non-real. Okay, that's where I is involved. So on this one, I would have written 2 non-real, or maybe none first. No real roots. Okay, because we know it's going to be a graph that doesn't cross the x-intercept. It doesn't cross the x-axis. Okay, so the answer would be no real roots. And I'm not sure how they would word it. I'll have to pull up my, my test generator.